I'm just riding on my bike and
Math. Some of you love it, most of you hate it. But hate it or not, math is an important subject used in many things in our life, or even work. Why? Because math is considered a pure science. Why? So while most science like biology or psychology typically don't have legitimate proof if the stuff's true in it, or if maybe its origins even, math be like
1 plus 1 equals 2.
and 1 plus 1 will always be true no matter what you say, no matter what any dumb brain said. 1 pen, 2 pen, 1 car, 2 car. You see, math is entirely proven logic. It's no wonder why many people despise it, because there is only one, sometimes two, answer to an equation, and that answer cannot change no matter what. But there is one subject that where this rule, from what I see, don't apply. And that's trigonometry analytics. For those who aren't familiar with what trigonometry analytics is, basically you have to know what trigonometry is. Trigonometry is studying about triangles. Or to put it simply,
Yes, this triangle here is made out of triangle.
tan cos is a ratio to determine the three lengths of triangles. If you understand the three lengths of the triangles, there is the front, down, and hypothalamus. So sin, tan, cos has their own special numbers in each different angle value. To better remember different angles, with tan being sin divided by cos, so really all you need to know is sin and cos. And lucky for us, they're the opposite of one another. What does these numbers mean? Well, to picture it,
30 degrees, since sin equals front divided by hypo, and front is 5 centimeters, and sin 30 degrees equals 1 per 2, then 1 per 2 equals 5 per 10, meaning hypo equals 10.
That's basically what trigonometry is. Special angles are basically angle values that are easily written. These are 0, 30, 45, and 90. But what happens if they ask, well, what is sin 75 degrees? All y'all might say, it is sin 45 plus sin 30 degrees. But I'm here to tell you, that ain't the case. Y'all, it's like saying 2 times 2 is the same as 2 plus 2. Wait, it's like saying 3 times 3 is the same as 3 plus 3. No, it ain't the same. Oh, believe me? Go to your calculator and type sin 45 degrees plus sin 30 degrees. Then type sin 75 degrees. It ain't the same. So how the heck do we solve this? Well, this is where trigonometry analytics come in play. Well, trigonometry analytics is a sub-branch of math that studies the relationship between trigonometric identities. My god, that's a tongue twister. Basically finding non-special angles. So how do we do this? Well, we use the formula of cos A plus B equals cos A times cos B minus sin A times sin B. Cos A minus B equals to cos A times cos B plus sin A times sin B. Sin A plus B equals sin A times cos B plus cos A times sin B. And sin A min B equals to sin A times cos B minus cos A times sin B. Why is it like that? I don't know, man. It's like they just grabbed the logic and used it into the back rooms. Good luck finding crap in Google, cause I've been searching for hours and I didn't find squat. But as Hipparchus, the founder of trigonometry, once said, if it works, it works. Shut up. Now we know the formula. How do we solve sin 75? Well, sin 75 can be said as sin 30 plus 45. But question, isn't that the same as sin 45 plus sin 30 degrees? Actually, I asked the same question to Miss, and I thought she was just changing the rules to her liking. But it turns out that's not how you math. Why is this video and audio different? Well, I'm recording this in different days, and not all at once. Even though this video will be around 6 minutes long. Alright, back to the question. So sin 45 plus 30. That looks very familiar, does it? So to do this, let's just say A is 30 and B is 45. Put it in, you get something like this. Now just remember the trigonometry table for each of the angle values, multiply, if you know how to that is, and or subtract them up, and you get the answer. Now that you know how to do it, Just follow the same steps with different questions similar to this and you're pretty much good to go. Keep in mind, this is just a simple version of this, believe me. The difficulty of my video might feel like playing piano tiles, but what Miss gave us feels like playing freaking Osu Centipede. But nothing is possible without practice. So if you want not to be big brain like me, there is no secret. Just practice and find your own way of learning such math. If you want to, that is. I'm being forced against my will here. So, are we done here? Heck no. There is more. A lot more. You see, math is about proving if an equation is correct or not. But it's also about finding other ways to interpret such equation. In this case, trigonometric analytics is way more than just one formula. We have others like sin 1 per 2x equals to root 1 minus cos x divided by 2, cos 1 per 2x equals to root 1 plus cos x divided by 2, tan 1 per 2x equals to root 1 minus cos x plus divided by 1 plus cos x. First question, why is it turning like this? Well, it is a downward of the first equation, where a and b are both the same numbers like x, and doing a bunch of math, you get this. Technically, you don't need to remember this, since all you need to know is how to downwards the equation to the other one. So, what do we use this for? Well, we use this in questions like, what is sin 15 degrees? You can say that sin 1 per 2, and then you can say x is 30 degrees, so 30 times 1 per 2 equals 15 degrees, and then put 1 minus cos x, x is 30 degrees divided by 2, and then root it, and then you get that. Or you can just minus sin 45 minus 30, and then use the first equation. It really depends on your taste, and if the question is even possible if you use the first equation. I'll be wondering why the first question is like that. If it works, shut up. Shut it. We ain't done here. We got another equation, which is sin a plus b plus sin a min b equals 2 times sin a times cos b. Sin a plus b means sin a min b equals to 2 times cos a times sin b. Cos a plus b plus cos a minus b equals to 2 times cos a times cos b. Cos a plus b minus cos a minus min b equals to negative 2 times sin a times sin b. Why is it like this? Well, it is another version of the downward spiral you call trigonometric analytics. Basically, if you add or minus sin or cos a plus b with sin or cos a minus b, based on the same thing, sin with sin, cos with cos, you get something like this. This is, for example, you say, what is cos 72 degrees times cos 8 degrees? Now, this won't give you a straightforward answer, but rather simplifying what the question is. Basically, just gotta match the equation with the equation together. So let me say, this looks very familiar to cos a plus b plus cos a minus b. So let's just say that cos 72 degrees is a and cos b is, or b is 8 degrees. Put it in, you get something like this. And then you do the math, blah 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 blah, blah, you get the answer. Not technically the answer, cause it is just a simplifying form of it. And finally, to the last equation, y'all remember earlier with the isn't that the same as sin 45 plus sin 30 degrees? Well, that's an entirely different equation, which is sin a plus sin b equals 2 times sin a plus b divided by 2 times cos a minus b divided by 2. Sin a minus sin b equals to 2 times cos a plus b divided by 2 times sin a minus b divided by 2. Cos a plus b equals to 2 times cos a plus b divided by 2 times cos a minus b divided by 2. Cos a minus b equals negative 2 times sin a plus b divided by 2 times sin a minus b divided by 2.
Anything familiar?
Well, if you were to replace a and b with alpha and beta, specifically alpha plus beta equals a, alpha min beta equals b, then you do a bunch of adding and subtracting, then it would look like this. If they thought throwing the logic to the backgrounds wasn't enough, they decided to rescue it and then shoot them to Brazil. I'm just cracking jokes right here. Of course there's a logical reason why this equation is like this. It's math after all, but I can't seem to find it. But if it works, it works. You folks know the drill, so to do this, we just gotta think, sin 45 degrees plus sin 30 degrees. That looks like sin a plus sin b. So you just gotta do 2 times cos a plus b divided by 2 times sin a minus b divided by 2. You just put it in. Just say 45 degrees is a, 30 degrees is b. Put it in. You get something like this. Now, I don't know what cos 37.5 degrees and sin 7.5 degrees is. So let's just leave it like that. Or you can use a calculator. Whew. That is all of the entire equations of trigonometric. So, are we done here? There is one final equation in the trigonometry analytics, and it has nothing to do with the first equation being a downward spiral. No, it is a completely unique equation you have to memorize by yourself. This equation is a times cos x plus minus b times sin x equals r times cos x min alpha, and a times sin x plus minus b times cos x equals to r times sin x min alpha. With r equals to a square plus b square root, and alpha is tan b per a. You might be saying, hey Sebastian, what is tan negative 1? Well, usually if it's in numbers, it is 1 per tan, but since in this scenario, it is more of the angle form of tan, not the angle value of tan. This is for if they ask you what is example 2 cos x plus root 5 sin x minus 1. Keep in mind, this equation is completely reversible, so you can just say 2 is b and root 5 is a, or you can just say 2 is a and root 5 is b. But remember that the equation or the formula will be different. So to do this, all you need to do is to first find the formula that you're gonna use. Is it r cos or r sin? As you can see from this, a cos x plus b sin x. So we're gonna use the r cos. As I said before, the formula is completely reversible, so you can just use a sin x, r sin, but you're gonna need to change the 2 and the root 5 first. But it's all up to you. So secondly, we're gonna need to find both r and tan negative 1. So you can see that r is a square plus b square root. So first you're gonna need to root 2, you're gonna need to power 2, and then you're gonna need to power root 5. So as you know, power is basically a times a. So what that means is that if root 5 times root 5 will always be 5. As I say, root times root will become whole number. So after you've done that, you got 4 plus 5, add them, root them, you get 3. So now we're gonna find tan negative 1. So this is b per a, so it is root 5 per 2 tan. But the problem with this is that we don't know what root 5 per 2 is. So how do we do it? Well, we don't need to do this. It's okay if you put it in the value form, root 5 per 2, and not the angle form. Or if you have OCD, you can bust out the calculator. So all you need to do is just put the root 5 per 2, put the r in, and then you get the final equation, which is 3 cos x minus root 5 per 2 minus 1. Why minus 1? Because in the equation you can see that there's a minus 1 in the root 5 sin x minus 1. So we put it there. What is this? Well, this is basically a graphic equation. If you put this on a graph, it'll make a line based on the equation you put it in. As you know, sin and cos graph looks all wavy, so you could see that it has its maximum and minimum points. That is what we're trying to find. But how the heck do we do this? To do this, you gotta know the characteristic of sin and cos. Basically, sin and cos can't go beyond 1 or under negative 1. Why? If it works, so in this case, the cos x minus root 5 divided by 2 thing cannot go beyond 1 or under 1. So all you need to do is change that to 1 and negative 1, and then count it, and then you get the max and min value. And that is how you do trigonometry analytics. So what lesson did we learn from this? Well, obviously math, But I think what the lesson is mainly through all the math is that although math seemed very hard, maybe impossible even to the average high schooler, it's really not that difficult if you know what you're doing. It's just very tedious with how many rows and numbers you need to write and all of the downwarding crap thing. Math is like holding 6 glass cups in both hands. Don't get distracted and let go of even a single cup. In this case, the cups are, if you miss right or miss not right, a single digit of number or variable. Cause, like a building, if one block cracks, the entire thing will crumble. Just like math, if you miss a single number, the answer will be completely different. But it ain't that hard if you have the right tools and how to use them. In this case, the crap ton of formulas Miss gave us to remember. But that's all the time I have. Thank you so much for watching, and time to let out a scream of relief.